Hey everyone, welcome back and welcome to our last lesson for the week. Again, Fridays, I'm not giving you any work. You can use that day to make up any work or you just review some of the materials or sleep in. So today is ocean temperature at different locations. And again, this is Unit 6, Chapter 2, Lesson 2. And this lesson also focuses on that article that we read in the last two, The Ocean and Motion. And if you haven't read it, again, the last two lessons, this lesson and the one previously, won't really make sense. So it's a good first step if you're just tuning back in. So during the warm-up, so you should be able to, let me just go right on to the Amplify website. Again, if you click on the link, it should bring you right here. And we have two places on our map, Buenos Aires and Cape Town. Cape Town is in the southern tip of Africa, and Buenos Aires is in Argentina. If you were in 608, you would have remembered this city from our dancing class, as this was talked about when we were doing one of our dances. Now, if we look on the map, they're pretty much on the same latitude line, and we already have some information about latitude line and temperature. And the question they're asking you is, do you think the ocean surface temperature near Buenos Aires is the same or different from the ocean surface temperature near Cape Town? Look at the map and then select prediction A or prediction B. Now, it's also going to ask to explain your choice. From looking at this from a basic standpoint, it looks like they would probably have very similar since they're on the same latitude line. So my choice would be that they're the same. I think this because they are located on the same latitude line. This is a very, basic understanding of that anything around the same area should have the same temperature. And it's asking about the ocean surface surrounding these areas. Both of these are on our coastal cities. When you're done responding, if you chose a different answer, that's fine too. And you can just press hand in and move on to the next activity, where it asks you to reread. Now, I would ask that you guys reread on your own time. Remember, the more times you read something, the more information that's going to stick with you, and maybe even give you some different perspective. So during the warm-up, we predicted surface temperature near two cities with the same latitude. Today, you will be getting evidence for things other than latitude that can determine the ocean surface temperature. Now, the Chapter 2 question is, other than latitude, what else can affect the air temperature of Christchurch? Now, previously, we read the article about ocean currents, and if you guess, if Chapter 2 is all about ocean currents, we're going to learn about how ocean currents can change the temperature of a location. So, a key concept here is when an ocean current comes from the equator, it brings warmer than expected water to the places it passes. When an ocean current comes from a pole, it brings colder than expected water to the places that it passes. So I want to look down at the map they give you on Amplify. So I'm going to go back to the Amplify website just so we can see it how you are seeing it. And again, you can press update and go on to the next activity here. And let's take a look at this, investigating the temperature. Now, if we compare this, we know that equator water is going to bring warm water, and over here it's going to bring polar water, the closer it gets to the polar parts of the map. So if we look at line A, it starts here and goes down here, whereas line B starts here and goes up here. If we are to compare the two currents here, they both carry energy because none of them are coming from absolute zero, but I would say that B carries less energy than A because it's coming from a colder place. The colder the water, the less energy it has. So B would have less energy, whereas A has more energy. If I'm just comparing them to each other. Now, down here, it asks you to save and continue because we're gonna go into the explanation of this. I want you guys to think if current means the movement of water, right? And we look at this map here with the current. Cold water is moving up and hot water is moving down. So here, right here, when it mixes, it's getting mostly colder water, whereas over here, it's mostly getting hotter water. So if I were to choose a claim and try to explain which one is better supported, Buenos Aires and Cape Town have the same ocean temperature, or they have different ocean surface temperatures. I'm going to say that they're most likely different. And I want you guys to explain why you think I would choose that they are different, and make sure you use the word equator, energy, and current. And I'm going to write answers so that I can move on. Now, I'm going to go back to my slideshow here and press play. So I'm already giving you the answer that A is warmer because it's coming from the equator and B is colder because it's coming from the polar zones. But let's take a look at the average ocean surface temperatures on Earth. And keep in mind the two arrows are located that are from this map. As you can see for the one near Buenos Aires, it starts at the equator, and look how that water is it goes warmer for a longer period of time. It pushes it all the way down. Whereas if you look at the water near Cape Town, and since it's being pulled from the polar zones, it's colder. And it keeps pushing up it's pushing the cold water up. Whereas in the Buenos Aires area, it's getting pushed down with warm water. So on this map, we can see that this current changes the surface water. Now, I want to make a connection that surface water, or any surface temperature from land or water, can change the temperature of the air. Because remember, air, we learned from chapter 1 that air gets its temperature from the surface. So if in Cape Town the ocean water is cooler, there's less heat coming off the water or the surface and being mixed into the air. Whereas in Buenos Aires, there's warmer water or warmer ocean surface, which would leave more heat to go into the air. When an ocean current comes from the equator, it brings warmer water, and when it comes from the pole, it brings colder water, and it passes it through, and it goes into the air. So if we're going to go into the chapter 2 question, other than latitude, what else can affect the air temperature of Christchurch? We have to start thinking about the ocean currents. If the surface can be different temperatures because of water being pushed from colder or warmer areas, this could also change the temperature of the local areas that are near these ocean fronts. So, what you need to make sure that you've done for this, which is going to be graded, is answer this question right here about why Buenos Aires and Cape Town have different ocean surface temperatures. Because our next couple lessons are going to be about how these ocean differences or surface differences could change the weather in an area.